Bismillahirrahmanirrahim. Today's lecture is about triangulation survey at site near Aptabad Public School. So this is a general layout of the scheme. Baseline is around AB and we have a triangle DCG and a triangle AHD and a brace quadrilateral A, B, C and D and a parallelogram that is BEFC. This is the main road that is on which our rest house is located and our scheme is located. These are the number of angles, actually the numbering of angles that has been given to each, and you see that ranges from 1 to 22. So you have measured all the angles in your horizontal angle measurement job when you use theodolite to find out the horizontal angles. So we will use, every group should actually use their measured values, and on those measured values we will apply all the corrections. So this is the general criteria that we have. So the contour interval should be 5 meters, reduced level of station B is 1260 meters. Scale of the map that you have to draw is 1:500. The data given to you initially is that bearing of line AB you can use as 163 degrees. Baseline length you can use as 77.416 meters. And traverse length of the parallelograms BE, EF and FC are also provided to you. And these are the sample values for all the 22 angles. This is for demonstration purposes. What you should do is that you should use your own values that you have obtained in the horizontal angle measurement job. Now here is a list of the steps that you need to do for computations for plane tabling. So what you do is that you have to apply corrections on all the 22 angles before you start the plotting of scheme on your plane tabling sheet. So the first step is that angle measurement at station. So you have already performed in your horizontal angle measurement jobs, and then we apply correction of angles. And their correction of angles applied in 2 steps. First one is called as geometric adjustment, that involves station adjustment and figure adjustment, and then comes the trigonometric adjustment, which involves only brace quadrilateral adjustment. Okay, so and then we find out lengths of the line, bearing of the line, then we find out consecutive coordinate and independent coordinate. So let's move to the first thing, that is the geometric adjustment. So in geometric adjustment, that is for correction of angles, first thing is to apply station adjustments. And what is station adjustment? Sum of angles at a station should be 360 degrees. So we have to ensure that all the angles on a station should be 360 degrees. After that, we apply figure adjustment. So let's talk about station adjustment first. So for instance, you see here at a point A, we have angle 1, 2, 18 and 19. So sum of all the 4 angles should be 360 degrees. So we have station 1 and 2. So you see here the sum is coming to be 360.029444. That is, it is more than 360 degrees. So what we'll do, we'll find out the error. And how do we find out the error? Subtract 360 from this value. So we get this error. Now we divide the error equally in all the 4 angles. Now because the value was more than 360, so what we will do, we will subtract the correction in each angle. So error divided by 4 is this value, and we will subtract minus 0.00, sorry, we will subtract 0.0073611 from each angle, and we will get the values 1, 2, 8, 19, and once we add all the 4, the sum should be 360 degrees. So this is the station adjustment. So you will do station adjustment at all the angles, at all the points actually. So if you go back to the scheme, so you will apply station adjustment to A, B, C, D, E, F, G and H. Do all these summations, okay, and ensure that the angles are 360 degrees, and if they are not, then find out the error and then divide that error with the number of angles at that point, and then apply correction to all the angles in equal amount. Okay, after station adjustment we have figure adjustment. So in figure adjustment we will first do adjustment for triangle, and then we do adjustment for trapezoid, all right, and then we do adjustment for brace quadrilateral. So 3 adjustments we will do in figure adjustment. So after you have done the station adjustment, we will note the angles that we have improved, and then we will apply corrections on the improved angles. So let's talk about the triangle correction. So let's see that this is a triangle AHD and it has internal angles as 16, 17, 18. So we know that from geometry that the sum of internal angles should be 180 degrees. So you see here this angle 6, 18 and 17 are giving us a sum of 179. That means it has an error. So we subtract it from 180. This is the error that we get. Alright. And then what we will divide that error, this error with 4. So this is giving us a value of minus 0.286. So what we are going to do, because the sum was less, so we will add the correction in all the 4 angles, or the 3 angles, sorry. And once we add 16, 18 and 17 after the correction, the sum is once again 180 degrees. Now we come to the trapezoid adjustment. Trapezoid adjustment means that this is a trapezoid BEFC. We have angles 9, 10, 11 and 12, and the sum of all the angles inside a trapezoid should be 360 degrees. So we have angles 9, 10, 11, 12, and the sum is coming to be 359. So that means angle is lesser. So we subtract it from 360. So this is the error coming, total error. We divide it with 4 to give us the error that has to be accommodated in each angle. So what we're going to do is that we have, this is the correction that is required. So what you're going to do is that you are going to add minus 0.0345 in each angle 9, 10, 11, 12, and once we add them, this will give us a sum of 360 degrees. So this was the trapezoid adjustment. And then we have brace quadrilateral adjustment. Now in brace quadrilateral adjustment, what is the rule? The rule, you see here that we have brace quadrilateral means that we have braces. So this AC line is a brace and BD is a brace. So according to geometry, it says that the sum of angle 1 and 8 should be equal to the sum of angle 4 and 5. Similarly, the sum of angle 2 and 3, they should be equal to sum of angle 7 and 6. So you see here that sum of angle 1 and 8 is 101.3, 4 and 5 is 98. So you see there is a difference. So what we will do, we will subtract the two angles, subtract these two values. Okay, 101.3 and we'll subtract this value, we will subtract this value from this value. Okay, so and then divide the difference with 4. So this is value, that is 0.813 is the difference that we have adjusted. Now how do we adjust it? You see angle 1 plus 8 are giving you more value and angle 4 plus 5 are giving you lesser value. So what we do is that in angle 1 we will subtract 0.813, in angle 8 we will subtract 0.813, and in angle 4 we will add 0.813, and in angle 5 we will add 0.813. So you see that, so once you have applied correction, the both summation will have same value. 1 plus 8 will give you same value as 4 plus 5. Similar rules apply, 2 plus 3 and 6 plus 7. Find out the difference and then divide it with 4. So with that value which is giving you lesser value, add angles in that, add corrections in those angles, and which angles are giving you more value, we subtract. So this was brace quadrilateral adjustment. So these were the figure adjustment that we need to do. Now we look at the brace quadrilateral adjustment. In brace quadrilateral adjustment, what we are going to do is that we have to draw this table. So you see here angles are mentioned here which are within the brace quadrilateral. You see here they are 1 to 8. We'll go back to the figure and you see here that 1, 2, 3, 4, 5, 6, 7 and 8. These are the 8 angles. So we are writing them in this table. Okay. So after applying station correction, after applying figure adjustment, after applying the brace quadrilateral adjustment, what are the final angles? We will write those angles here. All these angles, they are after figure adjustment, after the station adjustment, after brace quadrilateral adjustment. These are the values obtained after all the corrections. And you see here once we sum them up, so you see here the sum is coming to be 362 degrees, giving us an error of 2.17, that is more value. So what will I do? I will divide this value with 8. Okay, so this gives me 0.272. That means in each angle 1, 2, 3, 4 I will subtract this value. So that means in angle 1 the initial value is 53.91625. I will subtract 0.2720 and this will give me value of 53.644. So similarly in all the angles 1 to 8, subtract this value 0.272, and once you add all the value, you will see that they will give you a value of 360 degrees. Okay, so this is how we do geometric adjustment, and we indicate with capital letter A. Okay, and then we will look at the values B. Okay, in values B, we will now, what are the value B's? B values are capital B values. They are obtained by the parallelogram rule. You see, I'll go back. Sorry, this one here. So this brace quadrilateral rule, that the summation of opposite angle should be equal to the summation of the line opposite to it. It should be equal. So after applying the correction, we will get the final values. They are indicated by this column B. Okay, I'll repeat once again. Column A values, they are obtained, sorry, the observed values, they are obtained after station correction and figure adjustment, and then we find out the difference, and we find out the error, and then we find out the value A, column A. And column B, how column B is achieved? This is simply achieved by applying this brace quadrilateral rule, that the summation of opposite angles should be equal to the summation of angles opposite to the line. Okay, so this is how we get column A and B. Now we find out small a, that is equal to log sine of B plus 10, and B is equal to log sine of B minus log sine of B minus 1 second. Okay, so find out the values A's and B's. Okay, and then we find out alpha, beta. Now how we find out alpha? So alpha means summation of even angles minus odd A values divided with the 8. So that means in this column, what will I do is that I will add first even A's. That means I will add angle 2 value of A, sorry, and then I will add angle 4 value of A. I'll add this value, and then I'll add this value. Okay, do the summation, and then I will find out summation of odd angles. That means this angle 1, angle 3, angle 5, 7. I'll find out A values for these angles. Okay, and then subtract even A's minus odd A's, divide with 8, so it will give us alpha. And how do we get beta? It is simply summation of angle value of B divided with 8. So you see here, this value B, sum all of these values here, all of these values here in this column B, they give us a summation of 1.72. We divide it with 8, so it gives us a beta of this. And lastly, we find out alpha for beta. So this gives us value 179.30 mean, and this value is in seconds. Okay, the value of alpha or beta, this value is in seconds. So what we are going to do is that add and subtract this correction accordingly. Okay, so what we are going to do is that in the odd angles we are going to add the value of alpha or beta, and in the even angles we are going to subtract the value of alpha over beta. So once you add them up, so this will give you a summation of 360 degrees. So this is how we correct the angles finally. This is the final value of the angles 1 to 8. Okay, then comes the process of finding the length of the line. So we will use similar sine rule, and sine rule says that A over sine A should be equal to B over sine B. So this means that I'll actually draw it here. So this means that if I have a triangle, okay, so if this is angle A, the length of this side is A. If this is angle B, the length of this side is B, and this, if this is angle is C, so and the length of this line is C. So you can simply use this formula to find out the opposite angles. So we have given you the value of baseline 77.416. So in this figure we know this length AB, okay, that is 77, and we know this angle 8. So this angle divided, sorry, so this length AB divided by sine of this angle should be equal to this angle, this length, that let's call this x, divided by sine of this angle 1 plus 2. So similarly you can find out each length of the line by using the law of sines. Then we find out bearing of the line. So we have been given the bearing of line AB, that is 163 degrees. So as this example is given here, that you have this line AB, and bearing means the angle of the line from north, so that is 163 degrees, and we know the angles. Okay, we know all the angles. We know this angle between BE, we know the angle between CE. So based on the values you can do the calculation for the bearing of each line. Okay, so find out the bearing of line AB, BE, find out bearing of each and every line following the process. Lastly, this is the last table that will conclude your calculation work for your plane turning sheet. So you see here we have stations. We have stations mentioned here from station B, D, E, F, C, G, A and H, and then we have lines B, D, D, E, E, F and F, C. We have their lengths, we have the bearing of each line, that is indicated with theta. And then we find out latitude. And how do we find out latitude? By this formula L cos theta. And what is L? L is the value of the length of the line and theta is the angle of this line. So L cos theta will give you latitude, and departures are indicated by L sin theta, length of the line into the sine of theta. So find out the latitude and departures. All right. So and then what we do is that we will apply correction by using Bowditch rule. So how the correction is applied is that length of the line into total error in latitude or departure over perimeter of the traverse. So how do we find out perimeter of the traverse? We can do that by, if we go back to the figure. So you see perimeter of the figure means length of line AB plus length of line BE plus length of line EF plus length of line CF, length of line CG, length of line GD, length of line DH and length of line AH. So add all these lengths, so they will give you the length of the perimeter. Okay, that this value, perimeter of the traverse. So for example, we want to find out correction in line BD. So what will I do? I will find out the length. So what I'm going to do is that I'm going to find out the length of the line. So this is the length 77.46. So this length will come here. And then it says, for example, I'm finding out correction in latitude. So I'll find a total error in latitude. So total error in latitude is this. So I'll write it here and then divide with the perimeter of the traverse. So this will give me the correction, that is this value. Similarly, find out corrections in latitude, find out the corrections in departures, and then after applying correction, we'll write the corrected values of latitude and departure. All right. So lastly, we will find out independent latitude and departure. And how do we do that? Is that we look for the least value, okay, and we look for the maximum value. So you see here, least value in latitude is 74, and the least value here in departure is, let's say, minus 0.3. So what we're going to do is that we are going to take station B as our base point, and we are doubling the value, that was 72, so almost double it to 150 and make it 0. So after that you will find out the independent coordinates of each station. Okay, that's all. So if you have any questions, so we can discuss them after the lecture. Okay, Assalamu alaikum.